Okay, here we go. Yeah. So I hope you guys had a very good weekend. The very long weekend. Enjoy yourself and had a good rest. I hope you guys had that. Maybe before I start, I just wanted to get like the um, thoughts from you guys. How many of you wanted to or is trying to break into data science? If yes, maybe you can give me a thumbs up so I can roughly understand the crowd that I'm working with today. Okay, cool. Okay, because there's a couple of assumption that I'm going to make here. I assume that you already roughly know a little bit about data science, what data science is, but we will still go through that. We will still go through um, go through what data science is, but the main focus would be what's beyond data science, like what's in the future of data science. Hence the topic of today, will there still be data scientists in the next 10 years? So we'll look into that because if anything that changes, we can actually act on it now and uh, do early choices. So when the 10 years come, you can prepare yourself much better instead of losing the data science job. So maybe that's the extreme case, but this is what I'm trying to, help you guys to get there. So let's get into it. I'm George, currently a data scientist in MoneyLion. We are a US-based fintech. We help elevate the uh, the Americans. And previously, I was a data scientist in Asia and also settled, working as a data scientist, building recommendation engine, ranking model, various prediction model, propensity model, all of that, and also doing experiment, A/B testing, quasi experiment. So full spectrum, full range of working in data science. And currently in the MoneyLion team, I'm working in the intersection between data science and machine learning engineering. So building solutions for the ML ops team. So ML in the ML ops team. So we help MoneyLion data scientists to do better in their job and uh, help them to create better products. So in terms of today's content, I think we'll still go through data science, a little bit on what it is, why we need data science, how it works. But the main focus is on the future and also touch a little bit on the roles in data science. If you try to get into data science, what you can do, what role that you can venture into that suits your personality or what you want in life, the future, and if you have time, the advice and the insights in the from the industry. So I like this explanation for data science. There is a lot of explanation, but Sequoia Capital put it very simply is that data science is scientific and truth-seeking discipline that uses data to extract knowledge. So put it into simple layman term is that data science is using scientific method to extract knowledge and insight from data. And the value that comes from data science is only realized if you act upon the knowledge and the insight. So if you only uses you extract the data out and the insights, but if you do not put it into practice, then you are not realizing any value for your company or for your organization. So data science only makes sense if you put it into practice after extracting the knowledge and the insights. So when you go back to scientific method, I think you learn scientific method in your secondary school, which is start with hypothesis, test with experiment, analyze the data, report the conclusion. It's the same exact method, only the technique that you use is different. So that's what data science is all about. But once we go into deeper, what makes up data science is that data science is a mix up of it's a mix up of computer science, math, statistics, and business knowledge. I like this chart, although there are other charts out there, but I find that this explains it in a much better term. So it is the intersection between computer science, math, and business knowledge. So without the business knowledge, it's not data science because you cannot realize or act upon the knowledge and the insights that you get from your math and in your computer science. And without that domain knowledge, you would not know, what problem you are trying to solve. There will not be problem there for you to solve. So computer science and math, you can get it from your university, or you can, learn it by yourself. But the main issue that I always see is the domain knowledge part, because you only get that if, two things: you work in a industry, you work in the industry already, you get the domain knowledge. Else you would have to, read, do your research, read on blogs, articles, and research papers, so you get to know how different industry approach different problems. Like your e-commerce industry, your machinery, your manufacturing, all of them have their different problems, and they require data science to solve it for them. So let's say if you come from a finance background, then most likely you can utilize your finance knowledge in the financial industry aspect by, adding in the computer science and your math knowledge to, build better model for financial institution, because, you have that wealth in financial uh, knowledge, So that's what data science is all about. So why it matters for company? I think money maybe. So, but for me, I think money is just the byproduct of it. Every business in the world, they exist to create money and to make money for them so they can sustain. And that's just the nature of capitalism. And else, if you're not making money, then you are doing charity. So, like I said, money is just the byproduct. But what exactly is, that matters is it should be a win-win situation for both the consumer and the business, which is the main reason. I think is just to make life easier for you and I. Maybe it could be for the consumer. It could be, you get better video content recommended by you, through the YouTube algorithm. You can get to watch not just random shit, no, sorry, random stuff around the internet, but what suits you. So I'm sorry for swearing. Maybe for the business itself, it's, they help them to make better decisions. So that what matters for them. In terms of, data science is that throughout the decade, actually 94% of the data that was created has been created in the past decade. So this leaves us with huge amount of data, because it's much easier for people now to get better internet connectivity, declining cloud storage costs, computing costs, and all of that actually leads to and also maybe more platform. You have your TikTok, you have your App Store, all of that actually makes product reach the consumer at a much faster rate. What it results in is that, usually when during last time, in order to reach 100 million active customer, maybe you need 100 months, because that's the case for iTunes. They need 100 months to reach 100 million active customers. On go, it only needs few days. So the amount of data increases exponentially throughout the decade, and this leaves us with, huge amount of data that we need to make sense of and turn it into knowledge that can help us to derive more value from it. So eventually, this leads to this. With combination of more products built, more internet connected, increases in terms of online spending, all of that resulted in huge amount of data that I've talked about just now. And so the key differences in every company right now is how they can successfully use analytics and to make sense of all of this huge data, unstructured data, for them to drive product innovation. So this is the onus is on the company itself to make sense of it using analytics. So this eventually leads to forecasting of outcomes and power production systems. They can use data science to evaluate the health of the business and ship the right product and features. So all of this is very high level, ship the right product and features. You don't know what is it, but we drill into that. We look at some example of how company approaches this. Is that, as you can see, I have a few examples here. There are numerous, there are countless company out there. A few examples would be in Airbnb. They uses machine learning powered search ranking algorithm to determine the right property listing for their customer. So this is just an example of how they can use data science, and how Uber predicts arrival time for their passenger. I believe that this is also used in Grab, as I heard from the Grab engineers. They are also using this to approximate how long would your food arrive, or how long would your driver arrive. Why do they want to predict that? Is because they can make sure that if food arrives on time, and so you don't get angry. And the Netflix recommendation system, getting how smart it is that it gives you, the right video or the right movie to watch, and so on and so forth. So this is just some example of how different company approaches it, including AirAsia, Settle, and MoneyLion. We uses data science on a daily basis. We build model and actually help drive business decision. So what I'm trying to say here is that data science is not fluff. It's real. A lot of people are saying that data science is just BS. It's just people are doing nothing, but it is real. Like, people are actually using it. Like, companies are using it on a daily basis to help them to automate decision and make life easier for consumer. So one thing to take note of here is that it will never go away. It will only get better and more complex in terms of what a data scientist would do. So the job will not go away, but it will evolve into different form that we will talk about later. So getting into the roles of data science, there is many roles, very confusing, quite confusing, many confusion around this. People would ask, what data analyst is and what data engineer is. I would say you just have to take note of little small minute details or minute differences that I will get into later. And the key here, like I said, is to understand their differences, but also rather than categorizing, who does what and what does not count, we should actually more focus on giving it, leave it some room for it to evolve organically. Because data science is so new, it only machine learning only come out in the 1960s with the rise of the perceptron. Only in the 1960s we have machine learning. Before that, it's math, statistic model, and data science only come about within this century and within this few decades. So it still needs time to evolve over time, and it only get complex and more specific. Getting into each role, we have the data analyst. This is not absolute, of course. We still also have to, there is also sometimes that, data engineer do data work. But if you can see here, the data analyst will mostly focus on, as I know, I've been worked as a data analyst intern before and observing data analysts work in their natural habitat. This is how they work. Most of the time, it would be on running insights, analysis, and turning insights, doing visualization through reports, chart, etc. But what differences between data scientists and analysts would be on the ML and AI portion of it would be at this portion where data scientists are more expected to train out model while getting the insights from the analysts. The analysts will tell them, what problem they are facing and how. So difference between these two is building model. This is very simplistic. Of course, some data scientists and some analysts would also build model. They are given the analyst title, but they are expected to build model. So I'm giving a very, very simplistic view. But another difference between two of this with engineers are mostly focused on the back end in terms of ETL pipeline, making sure that the data comes to the analyst into the warehouse on time, and they can get their data on a timely manner. There is no failure between the data pipelines, uh, and when people buy something like from the app itself, the data has been captured easily and sent into the warehouse precisely and accurately. So this is what the data engineer will do. And there are also times where data scientists are also expected to do ETL pipeline. So there are also instances where I cross over to the data engineer job role. So this is not the absolute law. And as we look, as like I said, there are many overlap. Some I also do analytics work. I also do engineering work, and as I observe how others do it, it's moving toward the same direction. Each and everyone that has been hired, they are expected to they have to do everything. So this is the direction that we are heading. Data scientists are expected to have data engineer related skills, because it could help them to better understand how data pipeline works, and why sometimes when they put their model into production, why it fails, why is there missing data. So they need to have the aspect of having the data engineer skill set, and while also having the analytical mindset of a data analyst, running research and running analysis before building a model. What they should do, they should actually run research first, they should run study to actually look into the feasibility, or do you really need to build a model, or it can just be solved using a simpler method. So as a data scientist, you need to do all of this while having the data scientist title. So 3-in-1, expected to do 3-in-1. And so that's the direction that we're heading, doing everything together and breaking down into looking into what a data scientist do on a daily basis would just be captured by this chart, where we formulate problem, we run technical analysis, we build the model, we run analytical studies, and synthesizing the studies and the models that we build together, so it achieves influence or impact towards the business. So it's a never-ending cycle. So it's a never-ending cycle. So in the day of life of a data scientist, there is no, you can't pinpoint down what you do on a daily basis. It's not fixed, so it's highly flexible. You're expected to do a lot of stuff in between. Like I said, you have to do analytics work, you have to do the engineering work. So I try to break down a particular project that I've done previously in Settle, which is a product propensity model. So product propensity model is, I'm trying to figure out whether or not someone that feels on Settle, feels their vehicle in Settle, would they more likely to use Mesra Store, or how to get them to use Mesra Store, so you can buy stuff from the Petronas Mesra Store after they feel. So this is a model that I've been working on previously. So it took 3 months, and you can foresee that every day I would do different things, and it depends on which stage of the project that I'm in. So during the initial stage, it would just be discovery, running analysis, running high-level analysis, studying whether or not I should do this model. Would there be a potential in terms of business value there is? So if you put this into quarterly basis, this would be in the first month. So when people ask you, what you do at this point in stage, this is what you will do. You will not be building any model, etc., etc. So this is what you'll do. And so it differs from time to time. And when it approaches the end, after you build the model, you have to run A/B tests, and once it's passed, the model actually increases business value. It increases more people using the Mesra store, then I have to put it into production long term. So I have to uh, put it into a long term use. So my work doesn't end at putting it. My work doesn't end here. Even the governance and the monitoring of the model, I would be part of it. So it's a never-ending cycle. I have to monitor after it's been there already. I have to monitor it on a daily basis or a weekly basis to see whether or not it's still making accurate prediction, or it's actually uh, not making accurate prediction, or is what we call model drift. So the work doesn't end here. So if you see the pattern here that I'm trying to tell you is that we are moving towards the future already, where previously, in Malaysia, we are just building model one time and doing it on a one-off basis, then we put it into shelf and we close it down. But once we move towards putting model into long-term use, then it comes to a point where we have to monitor and govern it. And that was never a part of data science itself, but we are now expected to do it. And which is real. In MoneyLion, we have problems in, models that were built 2 years before, 2 years back, and now it's failing, and sometimes it's not making the right prediction. There is issue with that, there is problem with that, and that it leads to, maybe a drop in terms of customer as well, or it leads to losses in terms of our revenue. So all of this is part of data science now already. So in the future, so moving towards the future, with the addition of 3 of these together, we have a new paradigm shift here, is that I'll get into later, what is called additional skill set that you will need in order to prepare yourself for future data science role. So like I said, when we put, I can't see it. So when we put machine learning model into production, the ML code, if you see here, the black portion, is very small. So it's very small. So let's say you're trying to predict whether or not someone is male or female, then that algorithm is only in here, the code is here. But in order to support this, you need all of this in order to support this small, maybe few lines of code. You need these huge resources, configuration, data collection, verification, allocating resources for it to compute, serving your model output to the customer or to the business. All of this require more resources and more people just to handle 10 lines of machine learning code. And as we get more complex and we rely more on more machine learning model, it poses a huge problem. There is a huge risk in this, is that let's say something fails here, then it would affect everything here. Or even maybe something's wrong in the data collection stage. It influences everything else later on. So if you change anything here, you are changing everything. So it gets complex, and the more we rely on it, the more riskier it is. So how do we solve it? Which comes the future, which is ML ops. So if you guys heard about DevOps, then ML ops is just the DevOps, but for machine learning model. So what it does is it's just a framework or a understanding or discipline that standardizes machine learning lifecycle management. Or the machine learning development cycle. We'll get into that later, but it just provides a standardization and streamlining of every processes there is. And why streamline? Because isn't it just a business problem to a machine learning model? Very straightforward, right? No, it is not. Because like I said, when you rely more on automation of the model itself, the model become more critical. And even the subsequent or the system that is handling the model also becomes critical. In parallel, we need to manage the model risk. and it becomes a top priority for companies right now. As we are building models in 2 years before, right now is the time where problems start to arise. Even with COVID itself, in AirAsia, COVID actually causes a lot of problem towards our model because it messed up the data set that we have, so when the model predicts that customer would do XYZ, they are not doing it because uh, COVID is there to disrupt everything. Even with just small COVID, it causes such a huge problem for most of the organization in the world. So what MLOps is it is like DevOps, but it's more focused on the machine learning aspect of it. And a lot of it also comes from the data engineering discipline. And a friend of mine talked about what MLOps is. MLOps is not a role, it's a culture. So you will not find an MLOps engineer. But last time they also say that you will not find DevOps engineer, but eventually there is. But at the moment right now, you will not find MLOps engineer because data scientists are expected to pick up the MLOps role or the MLOps knowledge. Right now, there are not yet any differentiation. So like me, I have to pick up this and learn along the way. So MLOps is not a role, it is a culture. Culture is how you do things. It's very abstract. It's just tells you how you do things. It means doing ML, machine learning, the software engineering way. Any one of you that has studied software engineering before, like me, would understand the software development lifecycle. Then you just only apply that to machine learning, then it is MLOps. And they are like DevOps and DataOps. They are not a role, but more of a mindset. So how you build up your MLOps skill is, my friend, put it here very easily, is you need to have a strong engineering background, baseline, and that is the key. Engineering here would refer to strong software engineering baseline or knowledge. I would assume if you take computer science or software engineering, then when you picked up MLOps, it will be much more easier for you when compared to others. So look into the ML life cycle. The ML life cycle, same. You define your business goal, or you have your problem. You define the business goal. You assess and understand. It is the complete data science cycle as well. You build the ML model, you deploy the model into production, and you iterate. And when you do this long enough, for a few years, you would figure out that there is many problems here, is that there are many dependency. Business goals changes all the time. Your boss would, your CEO will want different thing at different time of the year, then your model will have to change, your data would have to change because of that. Maybe sometimes the package that you use to support your model or your Python code changes, then stuff happen. Then you have to make sure that you keep track of all of that. And not everyone speaks the same language, are you sure that your DE, your data engineer, can deploy your model? Or it's better if you yourself deploy it because you understand it more better. Or maybe you can help others to understand your model much better. So you create a document writing out all the specific details of the model, and people can reuse that in terms intent instead of you doing it. So when you leave the company, it will not cause any problem. Oftentimes when data scientists leave, it leaves a huge hole where another people will have to fill in that hole and understand what this person has built before. So MLOps is here to solve that. And like I said, not every data scientist are software engineers. So they are not software engineers. So you need some time to help them to pick up the software engineering skill. So we talk about all the problems that we have, how messed up it would be if something goes wrong. So MLOps is here to provide accountability for model, or for the people that build the model. and also increases the transparency of the model, how model makes decision and all of that. And all of this also leads to lower risk. We call in terms of risk mitigation, you are providing monitoring because it is a framework. It would have monitoring involved, so it reduces the risk, and eventually also responsible AI, where you can explain how your model makes decision. It's tied to explainability very, very deeply. Yeah, all of this can be solved with MLOps. And eventually, how we do MLOps is, let's try to apply MLOps to a business problem, product ranking. So this is the MLOps workflow. This is ML workflow. We talked about just now, how risk mitigation and all of that. This is like putting it into practice. The absolute, this is telling you how you should do it. It is, like your software engineering development cycle or your DevOps cycle, but we apply this MLOps. So all your process from data ingestion to governance. This chart tells you how you can approach it. Where should you put your code? So all of this is the MLOps workflow. I will not go through, each step of the way, although you can get the full MLOps talk by me from my LinkedIn. I did it with somewhere before, going through every detail of it, what's in every step, what tools and what platform and what you need in every step. Like your monitoring, how you can monitor it, how you can analyze your data, your prediction data, or how you should save your model, etc., etc. All of this is in that talk. It's a very long. I don't think there is enough time for me to go through it today. But this is the MLOps workflow, and this is the future where data scientists are, like me, are required to understand the MLOps workflow and put that into practice. And as early as you can put this into practice, then it would solve a lot of problem down the road. So you would not have any problems you would reduce the risk of having problem in the future once you deploy your model. So as long as you adhere to this framework, then everything should be fine. So this is a feature. And next up is the advices and insight. So to go back again to answer the question, our main topic, which is, would there still be data scientists in the next 10 years? There will still be data scientists, but data scientists are expected to pick up MLOps. And who knows, maybe next year there is new stuff that you need to pick up that I don't know yet because I'm not from the future. So this is just one of it at the moment. It would also give you huge value if you know any of it. Recruiter look at them, hiring manager or companies now look at them, and so they don't need to retrain their staff, but they can actually just hire you instead because you already know what MLOps is and can just teach them. So how you can get there is, you can do internships, you can join more clubs, tech events, hackathon, side projects, reading more, volunteering, and writing blogs. Once you put your side project into practice already, you build it up, you can write it. So hiring manager can get it much easier. So what I'm trying to emphasize here is increasing your value in terms of how you can get hired easily. So this is already like, getting into the career part, helping you to get into data science much more easy. Breaking it down, I talk about all of this, and maybe I can give you a few examples. How you can read more. I always recommend this for people, and I believe people should read this more. Is Eugene Yan actually is a data scientist at Amazon right now. He compiled a list, table content of data science related topics like your quality, data engineering, feature store, etc. A lot of topics here that you can look into and look into how different company approaches data science. That's why we have this slide, because this is how, once you click into each of the topic, then you would see that he will provide the links to all of this, and you will see how different company approaches data science. It might give you more domain knowledge in terms of how the hotel industry does data science, and also how different people do data science. Give you more idea, more strategy, so that you can, when your boss asks you, how to solve certain problem, you would already have some ideas or some um, solution in your head that you can use. You can tell him that, hey, we can use recommendation engine, you can build this, you can build that to solve XYZ problem. So yeah, so once you have built your side project already, I would recommend that you write them out. I love writing. I have not write for a long time, but I find that writing it out helps me to explain stuff back to me, back to myself again, and also correct myself. And eventually, it also helps people to see your work, and also increases your personal branding, just helping you to get more reach, REACH, like more people to know about you. And how you can do side project, you can go to Fast AI, you can use Google Colabs, you can when I started, I used Kaggle a lot. Kaggle has a lot of data set and a lot of problems that you can work with. You can get their data and also just use their notebook to build your model, or to build your solution. Yeah, you can do all of that in Kaggle. And I think what gives the most value would be internships, because internship exposes you to the real world. Good news if you are in your first year, because even if in your first year you can do internships already. You can take that summer break, 2 to 3 months, to find a company to do internships. I think a lot of software computer science graduate or computer science student in US, even in their first year, they are already trying to get into Google, Facebook, and by the time they reaches their final year, they would already have 3 to 4 internships in their belt, under their belt already, and all of that increases their value and their worth, so can get their full-time job much more easier. So do more internships, exposes you to real problems in the real world, and it also gives you new expectation and new maybe you assume that data science is very fancy, but once you get into that company, it actually isn't. Maybe that's the case for you, who knows. So get as much as you can. What I did was I did my first internship in my first year at iCar, which is now under custom already, and second year in Kautim. So that helped me a lot in understanding real business problems, and sometimes, oftentimes, they don't even need data science. They just need data engineers and data analysts, because they are not at that stage yet. So it helps you to shape your thinking and helps you to understand what the real world is. And I hope you can do the same as well. And I guess to sum it all up, the future is there. There is still data scientists, but you need to pick up. It would be good if you can pick up MLOps, because I'm thinking that would be the future that data scientists are heading towards, and data scientists are expected to do everything, everything that is data related. One thing is that in Facebook, the data scientists are doing data analytics work. Unless they are research scientists, then they will be building models. So so it's moving towards all of this direction. But I would assume that MLOps, no, I'm putting a bet into MLOps that it is the future. So yeah, so that's the end of my long talk. Do you guys have any question?
Thank you, Josh. It was amazing. First time hearing ML Ops. Yeah, very enlightening for me. I'm also a software engineering student now, but I'm in my final year already. So I can't go to internship during my first year. Yeah. So any questions from the floor? Anyone? Jonathan, you want to unmute yourself?
Yeah, can you guys hear me?
Yes.
Okay, so hi George. I have a question here. So I am I'm interested in doing having a career in the data science industry. But the problem is I am a math student, so I don't really have an idea of how to actually integrate into that path. And also, I think going to internships isn't a straightforward option for me since I'm already in my last semester of my year two, which means my next semester is going to be my to be my start of my final year. So I'm kind of confused now. So any tips on that?
You're saying you're from math, right?
Yes, I'm
Mathematics.
from the math department.
Yeah, I think good news for you is that you don't need to worry that much. So I've met a few people from, biochemistry, bioinformatics, math as well. Math is actually an excellent pathway towards data science because you already covered the statistics and the math part of it. I think what you lack of right now, as I can think of, is the computer science aspect of it, of data science. My recommendation is there is CS50 courses by Stanford free on Coursera. You can take that. It gives you basic understanding of what computer science is. And once you done that already, you understand what computer science is all about. Another good course that I would recommend is Andrew Ng's machine learning. It's a very old course. You can take that. Andrew Ng's machine learning on Coursera. Let me write this down in the chat. Andrew Ng machine learning courses. And another one would be applied data science with Python. I think it is by University of Michigan on Coursera. I took that as well. I think that would be helpful for you. So first step is to enhance your computer science knowledge. Once you get that done already, you have the basic understanding, then you can move towards learning how to use Python, how to build model, how to build model with Python. So once that's done, I think you are already more than ready for a data scientist job already. Yeah, I hope that helps. And adding on, also read up. Like I said, read up on ML ops because you are expected to do that when you get into the job itself. I hope that helps.
Yeah, that really helps. I have an additional question. Is it okay if I ask it?
Yeah, go ahead, Johnson.
Okay. So this is about choosing an internship because I'm not sure what kind of internship I can actually choose with my current background.
Can you emphasize further, like your doubts? Because the straightforward answer would be to get a data science internship.
Yeah. Okay. So the situation is like this. For our university, the internship period is quite short, and it has been a problem for quite some students to find an internship. It's basically like I think 5 weeks, if I'm not mistaken.
5 weeks
for my course. That is really short. I know that. So I've been told by seniors that it's really hard for us to find internships, and me without having a corresponding background, I think it adds to the difficulty. So any tips on that?
This is very difficult if it's 5 weeks. I try to make good use of it. So if you see the daily life of the data scientist of me, it takes about 3 months to realize a model. So I've not answered the question yet, but I think you should tell your dean or something to increase the the length of the internship. So that would be it. But another thing would be with 5 weeks itself, I would say if you can get an internship, so the main focus here is now is not on building your data science knowledge through internship already. You need to build your data science knowledge from outside, like your online courses, your surf, your personal project. You can't rely on internship, because it's only 5 weeks. So, but if you did get an internship for 5 weeks, it would add up as a work experience, as long as you have work experience, it's good already. But the bad thing is you can't get data science exposure from it. You have to get it from outside of internship. Do you get what I mean? It gives you work experience, which is very good in putting into your resume, but it can't be the main source for you to learn about data science. You have to get it from somewhere else. Like no choice but have to rely on online courses and etc. But
okay. Thank
if
you,
you can,
Yeah.
if you can get, make some changes towards the institution, perhaps increase it to 3 to 6 months. So yeah, maybe through student council or something, who knows? Yeah.
Okay, thank you for the questions, Jonathan. And I think maybe you can check. It should be 6 to 7 weeks, which didn't help much. But also before you proceed with internship, you might need to check with your school, because I don't think you can take something not related to max for your course. Okay, next we have some questions in the chat box from Lily.
Yep.
What are some good reads you can recommend for data science related books?
This is good. Actually, I'm sharing my screen just now. Let me let me share it again. The resources is in the slide itself. 1 second. Okay. Let me share my screen again. It's not the end. You guys can see, right? So resources is here. I think what are good reads? I think Engineering MLOps by Emmanuel Rush. Data Eco Team, Introducing MLOps. I love this. I love this book a lot. It gives me a lot of enlightenment. But this is what MLOps expect. But in terms of data science, I think I'm looking at this. This helps me previously. There is 10,000 books out there, but I think this is it. Like this is the, when they have the elements of the statistics learning, and this is the for data science, this will be it. Cracking coding interview, this will help you to get through your technical assessment during your data science interview for your job. System design helps you to understand how you can integrate your machine learning model into existing systems, or just designing better, or just helping you to your system design interview much better. And database marketing, this is a very old book, but it's full of gold. It gives you very simple concept of how you can do data mining and how you can use not data science but data mining. Like this is the oldest form of data science itself. Yeah, so these are some of the resources that I recommend. I can share the slide later so you can look at them, find pirated version of the book, and yeah.
Okay, thank you, Josh, for the sharing. And then next up, we have another question from Yongjun. Is there any personal project ideas to display your data analyst skills that stands out to top companies like Amazon, Microsoft?
Good question, Yongjun. To be honest with you, I don't have a list of it, but I have one project that I uses last time when I don't have a job experience yet. It was a Pokemon data set. So that Pokemon data set is in Kaggle. So it is the Pokemon data set, because in the Pokemon data set, each line will be each Pokemon, and it has all of these stats. You can do analysis on this. You can visualize stats, can visualize their HP, etc., etc. This helps you to show your visualization skill. But additional thing is that you can do classification, or you can do, you can do clustering. You can cluster your Pokemon using k-means based on their stats. That will be your machine learning skill set really. But this is Pokemon, right? How this would stand up is that you can treat each Pokemon as a customer. So when you tell your recruiter, or you tell the hiring company, is that even though you do all of this analysis on this Pokemon data set, but you can tell them that you treat each Pokemon as a customer, and you can tell them that you can find high value customer from data set, or if you can find strong Pokemon, you surely can find high value customer for them already. So this would be it lah. So you try to find projects like this and try to frame it into a business problem or business value. So during your interview, you can, elaborate them to your interviewer. So they don't just see you as doing a Pokemon analysis, but rather a customer analysis. Yeah.
That is very, very interesting. And I assume people who play Pokemon last time, they would really like this idea also. Next, I hope this answers Yongjun questions. Next, we have Hong, who asks, as a final year student of civil engineering, so to join as a data scientist, should I take master in data science? How would it help to secure a job of data scientist while the computer science skill is not being that emphasized in the course? And Jonathan also shared that question.
Yep. I think the quick answer is, when I observe, is that don't spend, if you are a student right now, like I said, you're still young, don't spend that money to do data science master. Truth to be told, the things that they learn in data science master, you can learn it in Coursera, and even Coursera is much better than it. So don't spend that money in that. So master is only if you are already working and you want to transition into data science. You need some credentials, you need some things to tell people that you know data science. So only at that point you take master in data science. But if you are a student, don't spend that money. I don't think you have the money as well. Don't spend that money. Learn all of that in Coursera, online courses, side project. You have that luxury of time. So use that time to do this. People that work like me, we don't have enough time. We work from 9 to 6 every day. But if you are a student, you still have a lot of time in your daily life that you can learn all of these courses, get all of that certificate instead. So you can tell them, even if you are a civil engineer, you have all of this knowledge, you have all of this certificate, you've built this side project, and that will be enough. If I hire, I don't look at which uni or what uni that you do. I will look at your job experience or the project that you work on. If you are looking for a data science internship or a data science role. So yeah, masters is not important for you if you are a student right now. Yeah.
Okay, Hong, I hope that answers your question. Yeah, maybe I would like to ask another question, because I'm also a final year student now, and I'm in my final semester, and then I will enter internship and then graduate. So would you advise me to start working for a few years first before I proceed to take a master? Or will you think yes, I can after graduate, then I go study some master program first before I start going to in career, not data science, but maybe IT career, because I'm a software engineer student. Yeah.
Yeah. Well, maybe I can ask, what master do you have in mind?
Actually not really yet, but maybe masters in cybersecurity or something like that, IT. Masters in IT, not MBA.
Got it. I think for software engineers, masters is not important. And there are people that reaches staff software engineer L7, very, very experienced software engineers. Maybe they don't even have a uni degree, or they don't even have a master. So you take master only if you know what you are doing. let's say if you are really interested in economics, then you took an economic master. If not, I would say don't waste that time in doing a master, but focus on building up your technical skill, how to manage a software engineering team. Spend your focus and resources on that. Yeah, unless you have a different purpose on getting a master. Let's say you get a master in business administration because you are trying to learn how to manage company, then that would be your choice. But if not, if you are still in software engineering, I don't see a value a master will add into your career.
Okay, I understand. Thank you. Hong added up to his question. So he's asking if instead of taking master in data science, he should take certificates from Coursera, or can he take like another 4 years of bachelor degree in computer science because he wants to change the career path. So I think he wants to change from civil engineering to, yeah.
Yeah, I don't think he should take another bachelor degree, but yes, take the money, spend more on certificate. The point is not gathering certificate. The point is I can audit my course, like I don't get a certificate, but I learn from it. Like I get to know what data science is. And like I said just now, I meet a lot of people, data science, the power of data science is that everyone in data science comes from different background. There are civil engineers that turn into data scientists. I'm a software engineering student that turned into data scientists. They are mechanical. They are biotechnology student that turn into data science. There are even lawyer that becomes a data scientist. So it doesn't, like every job in the world, it doesn't matter maybe I cannot set every job, but there are a lot of jobs in the world. It doesn't matter which background you come from. You can get into it. And with your mechanical engineering degree, the knowledge that you get from mechanical engineering, it's very, very useful if you are working in a machinery industry or even a consultant role. It helps you, like that, it will help you a lot. So you just take the certificate from Coursera, it just help you to understand what data science is and getting hands-on, getting deep into it, what data science is, what computer science is. And with that side project, you are already building up, your knowledge in data science. You just need the chance and the opportunity to apply the side projects that you build into an actual business or actual company. So don't worry about, switching career. From a civil engineer, you can get into data science. It's not switching career, it's you can get into it. Yeah. So unless from mechanical to doctor, then different. You have to take the MBBS. But if you want to go into data science, no need don't need to worry about your background. It helps you a lot. As long as you study uni, it helps you a lot. Yeah.
Okay, I hope that answers your question, Hong. So it's 9 now. Before we end today's session, I would like everyone to turn on your cameras to have a group photo session with Josh. Yeah. And Josh, can you stop sharing your screen so that we can take a group photo together? Okay. Maybe few more seconds. One more minute. Hong, do you want to on your camera? Okay, I guess the others where we have someone turning on. Might get ready to. Okay, we have more faces now. Okay. Mike, do you want to count down or do I do it? To take the photo. I think you should do it to get a better picture of everyone.
I guess Tishan will take it. Yeah, because my Zoom got some problem.
Oh, okay.
Yeah.
Tishan?
Okay, counting down from 3, 2, 1. Smile, everyone. Okay, got it.
Okay.
Yeah.
Another one? Do we need another one?
Okay, maybe some freestyle one.
Okay.
Okay, 3, 2, 1. Oh, okay, got it.
Okay, thank you everyone. Thank you, Josh, for today's sessions. It really enlightened me a lot on data science, and I think our participants will find it very helpful also. So for our participants, you may watch the recording on our YouTube channel if you want to like rewatch and catch what George mentioned previously. And also, George, you would like to share your slides to the participants, is it? You want to share it now, or you can send it to us and we email them. That's a sim.
I think I sent it to you.
Okay, sure. Then we will do it and we will email to all the participants via your email. Okay, thank you.
Yeah. All right. Thanks,
Thank you,
guys.
everyone.
No problem. All right. Reach out to me on LinkedIn if you have any questions.
Yes, yes.
Good night, guys. Bye.
Good night. Bye-bye.